Hi there, just a quick point before we roll the intro. A lot of what I talk about in this section is not my own thoughts and words, but instead the thoughts and words imparted to me by this book, Clean Architecture by Robert C. Martin. If you're a software engineer or programmer of any description, like me, consider checking this out if you haven't already. Alright, roll intro.
1, 2, 1, 2, 3, 4!
As I've described in the past few weeks, I'm currently in a process of pretty deep introspection into a number of my projects. I'm taking things I've worked on in the past or will be working on soon and modifying the architecture or thinking behind them to make changes and updates to them smooth and easy. A large part of what I've been doing recently is trying to make my life of amendments and tweaks easier, which involves a lot of bug fixing and testing. But why bother test? And more importantly, how's the best way to test? For a long while in the course of some of my more archaic projects, I've had a fear of committing to them. And by committing, I mean literal project commits, not commitment issues. I'm not worried about my code not being functional or being frowned upon. I was worried about the sheer volume of edge cases. I would constantly be receiving reports or personally be experiencing bugs that are nightmares to find, which resulted in a lot of extra work on my part and a lot of stress on my end. But the weird thing about that though is that I like bug fixing. I love the process of finding the problem, getting context clues from the system, reviewing the work I've done and finally deploying the new fix. The problem is when there are systems so complex that many bugs can come in quickly and I don't have the time to enjoy the debug process or make airtight and versatile solutions to the problem, as what becomes a serious factor when a live piece of code experiences a problem. The user's viewpoint becomes the serious issue. Let's say that you're a user of a website. You're completing a sign up and just when you finish, you hit the continue button and the site refreshes. Your information isn't saved and there is no information on what happens. This is a highly feasible solution. If you consider that a network error fails, causes a relative redirect to nowhere, and that's it. The page refreshes with no knowledge of the error ever happening. From the user's perspective, that's a very, very quick way to lose a user of your service. Now imagine that a sign-up is happening every minute. You could lose a user every minute. And that is where we can see the problem and why speed is of the utmost when solving these problems. But what if we could prevent these problems ever happening in the field? This is where building unit tests alongside your code begins to show significant merit. Unit tests are pieces of code written to be run on deployment of the code that you're working on that effectively simulate regular actions that users may take. It automates normal, borderline, and erroneous testing using example datasets and reviewing the results. As many as these as needed can be built, and they can either be built into a deployment pipeline, into the startup of an application or container, or just run on their own. Using these unit tests are crucial to ensuring reliable code and can allow for swift updates with automated tests to ensure continued functionality. But this isn't actually the best way of testing code. The best way of testing code is before it ever reaches deployment. Run test servers, test functions manually, look for inconsistencies and errors and handle edge cases. This is the best way to test code, but the problem is that this takes time, the same as all other methods of testing. It ends up being a trade-off between how much time and subsequently money do you want to spend to make the code as stable as possible. It's not possible to make code perfect. Errors will always be possible and will always happen, whether it's due to code changing over time, users putting in unexpected data, or as far as a solar flare flipping a bit in your memory. Code will break. Code testing allows you to delay that occurrence, and hopefully that effect, combined with good architecture, can help keep code easy to change, easy to fix, and stable. I'm still working on rolling out comprehensive testing and architectural changes to my projects, and I'm looking to offer these developed skills to new clients. My software engineering business, Nickel Software, that builds commercial and personal software for any and all needs, is looking for new clients. We can build anything from simple informational websites to responsive services with desktop integration, and we're happy to provide and service websites, mobile apps, commercial desktop software, and server-side applications. For more information and contact details, please head to nickelsoft.co.uk. Thanks for your consideration. Pretty smooth.